stay safe. But find that and every conversation explore that of thinking beyond the obvious. And today I have my special guest. He's a professional software engineer, no other than Mr. Akshay Aggarwal.
Hi Daniel.
Well, welcome, Mr. Akshay on Abstract Akshay. And can you please introduce more like yourself that
First of all, Daniel, thank you for inviting me. Really excited to be here and have the discussion with you. And I'm Akshay, and my journey in tech didn't start in a computer science lab. It started in a small town in India, taking apart hardware just to see why it wouldn't boot up. The raw curiosity for fixing broken things eventually led me to the world of massive scale distributed systems. Over the last decade, I have specialized in backend performance and CI/CD architecture at companies like HP, Workday, where I was focused on tuning query engines to handle massive multi tenant loads. Today, as a principal engineer at Palo Alto Networks, I have shifted my obsession towards the future, architecting AI driven systems that use production data to build self cleaning, intelligent testing frameworks. My mission is simple: bridging the gap between deep system engineering and rapid automated release cycles.
and thank you so much for sharing your knowledge and wisdom to the world, Mr. Akshay. Thank you. And today let's talk about demystify AI-driven testing and RAG powered test generation in practical terms. So tell us, Mr. Akshay, AI-driven testing sounds magical and mysterious to many engineers. If you had to explain in plain language what is actually happening under the hood without buzzword, or how do you describe what is AI in doing when it generates test case?
So, if you strip away the buzzword, AI isn't thinking, it's pattern matching at scale. Think of it as a world classic mimic. When it generates a test case, it's looking at your requirement and asking, based on the million of lines of code and documentation I have processed, what is the most logical set of steps to verify this? It's essentially a superpower autocomplete that understands the grammar of testing. It knows that a login requirement usually needs a wrong password scenario and an expired session scenario. It's taking the repetitive thinking of your plate so you can focus on the strategy.
Interesting, Mr. Akshay. You're likely to see teams try to use ChatGPT directly for test generation and up with generic, useless outputs. What is the fundamental difference between asking a raw LLM to write a test for a login page versus using RAG powered system? What does the retrieval part actually retrieve, and why does it matter too much and so much as well?
Yeah, this is the most important distinction in enterprise AI. Asking a raw LLM like ChatGPT, Gemini to write test is like asking a brilliant lawyer to defend you without letting them read your case file. They are smart, but they will hallucinate or guess the details. RAG, which is retrieval augmented generation, turns that into an open book test. Before the AI writes a single line, the system retrieves your actual API specs, your SKU configuration, and all the things you need for the testing, and your specific business logic. It hands that fact sheets to the AI and says, only use this information. That transforms the output from a generic guess into a precision engineered test case.
Interesting, Mr. Akshay. Our RAG systems are only as good as their knowledge sources. What should actually go into a test generation knowledge base? Is it just requirements document, or should include API specs or historical test cases or bug reports, user feedback, or how do you decide what's essential?
Yeah, a lot of teams make the mistake of only feeding the AI their requirements, but requirements only tell you how the system should work. To build a cynical AI that actually finds bugs, you need to feed it the full context. That means API specs for the technical boundaries, historical bug reports to show where the system is fragile, and even production audit logs to show how customer actually use the product. If you only give it the happy path requirement, you get a happy path bot. If you give it the bug history, you get a security researcher bot. The quality of the test is a direct reflection of the diversity of that data.
So, Mr. Akshay, LLMs are notorious for hallucinating, inventing plausible sounding but completely incorrect information. In testing, hallucinated assertion could be disastrous. How does RAG architecture specifically address these risks? Can we ever trust AI generated tests completely, or do they always require human review?
Yeah, that's a great question. In testing, a hallucinated assertion like checking for a button that doesn't coexist is a waste of time. RAG addresses this through grounding. We set a strict instruction. If the answer isn't in the provided context, say you don't know. We also implement source citations. When the AI generates a test, it must point to the specific paragraph in the documentation that justifies that test gap. Do we trust it 100%? No. We use the AI to do the 90% of the heavy lifting. But the final 10% human in the loop is there to verify the logic. We treat the AI as a very fast junior engineer who needs a senior sign off.
Very well said. Very well said, Mr. Akshay. You're taking documents, splitting them into chunks, and turning them into vectors. For non-technical audience, what is a vector in this context? How does converting a sentence about user authentication into a mathematical representation help system find the right knowledge when tester asks about logging testing?
Yeah, that's again a great question. Imagine a giant 3D map of every idea in your company. On this map, the word password and the word authentication are physically sitting right next to each other because their meanings are similar. A vector is just numerical GPS coordinate for that spot on the map. When you ask the system about login testing, it doesn't just look for the exact word. It looks at those GPS coordinates and grabs everything in the immediate neighborhood like encryption, tokens, and sessions. This mathematical representation allows the AI to understand intent and context, even if you don't use the exact technical terms in your prompts.
Interesting, Mr. Akshay. When a user types generate task for checkout flow, what happens in the milliseconds between that prompt and the LLM starting to write? Walk us through the retrieval step, and how does the system know which chunk of your knowledge base on relevant, and how does it rank them?
In the split second after you hit enter, three things happen. First, your prompt is turned into a vector, that GPS coordinate we talked about. Second, the system performs a similarity search against your entire database to find the top 5 or 10 chunks of information that are closest to your request. Third, it ranks them based on relevance. It filters out the noise, keeps the signal. It's like librarian who before answering your question sprint through the aisle, grabs the three most relevant books and opens them to the exact page you need. Only then is that info handed to the LLM to write the response.
Mm, thank you for that interesting facts, Mr. Akshay. You're not just asking the LLM write tasks. You are constructing an elaborate prompt that includes retrieve context, format instruction, and domain constraints. What makes a great prompt for task generation? What is the difference between prompt and produces 60 high quality tasks and one that produce garbage?
Yeah, a great prompt is all about constraints. A bad prompt is, for example, write a test for login. But like how it differs from a great prompt? You are a senior software engineer at a cybersecurity firm. Using the attached API spec, write a high concurrency stress test in Python. Focus on race condition. Do not use external libraries. The difference is night and day here. A prompt that produces 68 high quality tests provide a persona, context, and formatting rules. You have to tell the AI who it is and what the boundaries are. If you give it a vague word, it gives you a vague answer. If you give it a narrow lane, it gives you a masterpiece.
So, Mr. Akshay, some AI testing tools use deterministic LLMs, purpose built for consistency rather than creativity. In test generation, do we want the AI to be creative and find edge cases, or we didn't considered, or do we want it to be predictable and repeatable? How do you balance these competing needs?
Yeah, it's a very delicate balance. We want the AI to be deterministic in its output format, meaning it should never hallucinate a syntax error or a weird code structure. But we want it to be creative in its edge case discovery. We achieve this by keeping the temperature of the model low, which makes it less random, but providing it with a cynical knowledge base. We tell it, look at these five historical outages and find a way to break this new feature using similar logic. We want an AI that is a rule follower in how it writes, but a rule breaker in how it thinks.
Interesting, Mr. Akshay. Research shows RAG-based generation can achieve over 90% requirement coverage with fewer task cases than manual writing. How is it possible? Is that AI actually smarter about covering path, or is it just more thorough in ways humans can get bored or tired?
The minutes part is absolutely real for the generation phase. I can generate 50 case regression suite in 60 seconds, but that's not the whole story. You have to account for the setup, curating the knowledge base, and tuning the prompts. However, once the infrastructure is in place, the ROI is massive. The real time saving isn't just in writing code, it's in maintenance. When the UI changes, instead of human manually updating the 50 scripts over 2 days, the AI regenerates them in 2 minutes. That's where you see the 10x jump in velocity.
So, Mr. Akshay, one of the biggest promises of AI testing is self healing. Test that adapt when the UI changes. How does actually work? When a button's ID changes from the submit button to submit button 2, how does AI know they are the same element?
Yeah, in traditional automation, if a button's ID changes from login 1 to login 2, the test dies. It's brittle. Self healing uses the AI to look at the identity of the element rather than just its label. The AI says the ID is different, but the element is still a div. It still has the text submit, and it's still located in the bottom right of the form. It uses multimodal logic looking at the code, the location, and the visual appearance to realize it's the same button. It then automatically updates the test script and notifies the engineer. It's like a GPS that automatically reroutes you when it hits a road closure.
Hmm. A fascinating claim in the research is that AI generated tests often uncover edge cases human tester miss. What kind of edge cases in the AI finding that humans tend to overlook? Is it about combinatorial or explosion, boundary values, or something else?
Humans are great at logical edge cases, but AI is the king of combinatorial edge cases. For example, at my last company, we might test a large data upload. Human tests a big file. And AI will test a big file uploaded by a user with restricted permission during a database maintenance window while the network is throttling. It finds the perfect storm scenarios where three minor issues collide to create a major outage. It's that ability to cross reference thousands of variables simultaneously that uncovers the invisible bugs. Uh, Daniel, I think you're on mute.
Yes, thank you for that, Mr. Akshay. AI testing tools now allow product managers, manual testers, and business analysts to create automated tests by describing them in plain English. Is this actually working in practice? What does that feel like for non-technical team member to suddenly be able to contribute to the automation suite?
This is actually happening right now, and it's a game changer for non-technical or like product managers. When a PM can describe a business flow in plain English and the API and AI translates that into a Selenium or Playwright script, you eliminate the translation tax. The person who understands the business value is now directly contributing to the quality gate. For a non technical person, it feels like they have been given a superpower. They no longer have to wait weeks for a developer to automate their manual test. They can do it in real time as they define the feature.
Mm, interesting. And Mr. Ashay, when everyone on the team can create tasks, how does the dynamic between quart or QA developers and the product change? Does it create chaos with thousands of low quality tasks, or does it generally distribute ownership of quality?
Yeah, if you don't have an architect like setting up the guardrails, it can be a chaos. You will end up with like 5 or 1,000 duplicate tests. But you have a quality platform approach, it generally distributes the ownership. Developer own the unit logic, PMs own the business logic, and the AI ensure everything follows the company standard. It shifts the role of the QA team from being the people who find bugs to the people who build the system that ensure no bugs are created. It's a move from gatekeeper to enabler.
Mm, interesting, Mr. Akshay. For professional SDETS and automation engineers, all tools might feel threatening. Are we automating ourselves out of jobs, or is the role shifting? What should today's test automation engineer be learning to stay relevant in AI augmented world?
Yeah, like I think we are elevating our roles. 10 years ago, our value was knowing how to create a click script. Today, that's a commodity. The new value is in AI orchestration. You need to know how to build the rack pipeline, how to audit the AI's logic, and how to manage the quality data. We are moving from being cameramen who record the test to directors who design the entire production. The demand for people who understand both deep system and AI architecture is actually exploding.
Mm, yes, indeed. And Mr. Akshay, there's also important difference between low code, no code tools, and when should a team choose one over the other? Do they compete or are they complementary layers?
Yeah, think of low code as a molded plastic toy. It's easy to use, but you can't change its shape. AI is like Lego bricks, it's generative and adaptive. You should use low code for simple, stable internal tools, but for complex, velocity SaaS products, you need AI. You need the system that can reason through UI change and generate a fix. Low code is for simplicity, AI is for complexity at scale. They aren't competitors, they are different tools for different jobs.
Mr. Akshay, AI testing tools require high quality input, isn't it? Well written requirements, clean documentation, representative historical test data. For organizations with messy, incomplete, or outdated documentation, is it AI testing even feasible? Or where do they start?
If your documentation is a mess, AI is actually your best starting point. You can feed a messy pile of old Jira tickets and Slack logs into an LLM and ask it to synthesize a structured API specification. It is the ultimate data cleaner. You don't need a perfect house to start. You use the AI as the cleaning crew to build the foundation. Start with one small critical service, let the AI help you document it, and then use that clean data to generate your first AI driven test.
Nice, well done. Very well said, Mr. Akshay. AI can misinterpret of cosmetics EU or UI change as a functional failure or miss subtle business logic errors. How do we tune these systems to be sensitive to what matters without drowning the team in noise?
This is the principal level of the job tuning, the sensitivity. You don't want a test to fail just because a color changed from dark blue to navy. We train AI to distinguish between cosmetic changes and functional failures. We use a feedback loop. If the AI flags a false positive, a human clicks ignore, and the system learns that specific pattern for the next time. It's about teaching AI the difference between the house was painted and the front door is missing.
Mm. So, Mr. Ashley, to wrap up our discussion for today, where is the technology heading? Will we eventually have AI agents that not only generate tests but also diagnose failures, propose fixes, and automatically update the knowledge base? What is the next frontier beyond RAG powered generation?
Yeah, the next frontier is basically autonomous healing and diagnosis. We are moving away from test generation towards agentic QA. Imagine an AI agent that detects a failure in production, automatically creates a reproduction test case, identifies the buggy line of code, and opens a pull request with fix before a human engineer even wakes up. We are moving from quality insurance to autonomous system resilience. The AI won't just tell you it's broken, it will help you fix it.
Very well said, Mr. Ashley. So, can you please invite our listeners to support your projects or anything you want to promote on Abstract Effect?
Definitely, they can reach me out on my email. It's akshay.agarwal at ieee.org. If anyone is interested to work with me or they have something that they need help with regarding AI in QA.
Yes, people, let's support Mr. Akshay Aggarwal. Let's connect with him if you're interested about AI. AI innovation. So Akshay, thank you so much for your time.
Thank you, Daniel. It was pleasure talking to you.
Likewise, Mr. Marticam people, see you soon.